determine the current drawn by a 250-watt incandescent lamp operating at 120 volts, we use the power formula. The power formula states that power, measured in watts, is equal to voltage, measured in volts, multiplied by current, measured in amps. In equation form, this is represented as P equals volts times amps. To find the current, we rearrange the formula to solve for amps. This gives us amps equals power divided by volts. We are given that the power of the lamp is 250 watts and the voltage is 120 volts. Plugging these values into the formula, we have amps equals 250 watts divided by 120 volts. Performing the division, 250 divided by 120 results in approximately 2.833 amps. Therefore, the current drawn by a 250-watt incandescent lamp operating at 120 volts is approximately 2.8 amps. When dealing with electrical circuits and components, it's important to understand the relationships between power, voltage, and current. This understanding allows for proper circuit design, selection of appropriate components, and ensuring safe operation. The power formula, P equals volts times amps, is a fundamental concept in electrical engineering and is used extensively in various applications. Incandescent lamps, while not as energy efficient as newer lighting technologies such as LED, still follow the same electrical principles. The current drawn by any electrical device is determined by its power consumption and the voltage at which it operates. Calculating the current draw is essential for determining the appropriate size of circuit breakers, wires, and other electrical components. In practical applications, it's often necessary to consider the power factor of a load. However, for incandescent lamps, the power factor is essentially 1, meaning that the apparent power is equal to the real power. Therefore, the simple power formula, P equals volts times amps, is sufficient for calculating the current draw. To summarize, the current drawn by a 250-watt incandescent lamp operating at 120 volts is calculated by dividing the power, 250 watts, by the voltage, 120 volts, resulting in approximately 2.8 amps. This calculation is based on the fundamental power formula and assumes a power factor of 1, which is typical for incandescent lamps. Understanding these basic electrical principles is crucial for anyone working with electrical systems or devices. When choosing wiring size, consider the ampacity ratings listed in the National Electrical Code (NEC). Also, consider voltage drop when determining the appropriate wire size and the distance the circuit spans. Remember that electrical work should be performed by qualified individuals.